So for this next section, it says to solve the following rational exponent equations and to show your work. So anytime you have a fraction in the exponent or a rational exponent, you need to check your work. So that means on both 14 and 15, we have 4/3 and 1/3 in the exponent, so we have to check our work here. Check our answers. And it's not that I don't believe that you did it correctly, but inherent in the process, you sometimes get an extra answer. Which, if you look a little bit further ahead, notice number 16 also has fractions in the exponent, so you have to check this one as well. Whereas number 17 doesn't have fractions in the exponent, so you don't have to check number 17. But if anything that has a fraction in the exponent, you have to check it. All right, so let's go back to number 14. The fraction in the exponent is all by itself. There's nothing being added to the outside or multiplied to the front. So I am ready to undo the 4/3. To undo the 4/3, I'm going to raise both sides to the reciprocal, which is going to be 3/4. Now, before we get too far into this, we want to look at the exponent. The exponent of the original problem, the numerator has a 4 in it, which is even. So because it's an even problem, I'm going to have a plus or minus in the problem. That plus or minus happens on the very next step after you get rid of the fraction in the exponent. So I know right now, because there's a 4 in the numerator, that I'm going to have a plus or minus on the next step. Okay? So let's go back to the raising to the 3/4. The whole point of raising to the 3/4, the 4/3 and the 3/4 undo each other. The 3's cancel, the 4's cancel, and all you're left with is the inside, which in this case is 2x minus 5. Then I'm raising 16 to the 4/3. Now, we just practiced that, so I have the 4th root of 16 cubed. The 4th root of 16, that's 2, and 2 cubed, that's 8. Okay, and now I'm going to solve, so I'm going to add 5 to both sides. So that gets me 2x equals 5 plus or minus 8. Now, I know what 5 plus 8 is, and I know what 5 minus 8 is, so I'm going to actually have to break this up. I could do it now into 2 equations, but I'm going to go ahead and do it right at the end. I think it's easier if I just wait. So I'm going to continue to solve for x. I get x equals 5 plus or minus 8 over 2. And at this point, I'm going to break it up and actually figure out what the two answers are. 5 plus 8 over 2 and 5 minus 8 over 2, which gets me 13 over 2 and negative 3 over 2. So those are my two answers. I really should technically say potential answers because I have to check both of them, right? One common mistake students make is right here. They have plus or minus 8 plus 5. Instead of, I think the easy thing to do is just put the 5 in the front and plus the plus or minus 8 in the back. But sometimes they'll take 8 plus 5 and get 13 and put plus or minus 13, and that's wrong. 5 plus 8 is 13, but 5 minus 8 isn't negative 13. So just be careful there that you're not actually trying to do too much in one step, okay? So let me check here. Let's try x is equal to 13 halves first. So I'm going to plug 13 halves in, so 2 times 13 over 2 minus 5 raised to the 4/3 is supposedly equal to 16. Okay, I put a little question mark over the equals because I don't really know if it's true or not. That's why I'm checking. So the 2's divide out nicely, which is nice because you're like, oh no, fractions, but it doesn't turn out that bad. So 13 minus 5 is 8. So as long as 8 to the 4/3 truly equals 16, then I'm good to go. So that's the cube root of 8, which is 2. And 2 to the 4th does equal 16. It works. So 13 halves works. Clearly, I'm not going to have enough room here at all, am I? Let's see what we can do about that. So now I'm going to check the 3 halves. Negative 3 halves. So I'm going to plug in negative 3 halves minus 5 raised to the 4/3 is supposedly equal to 16. Sorry about my dog barking. So negative 3 minus 5, that's negative 8. So negative 8 to the 4/3 is supposedly equal to 16. So I'm going to swing over here and use some more space here. So the cube root of -8 is -2, and -2 to the 4th is positive 16. Yes, they both work, okay? So that was a lot of work just to check it, but you know, you're required to, so sorry about that. All right, the next one we have 1/3. Okay, notice that right now the numerator of the exponent is odd. So because it's odd, I do not have a plus or minus. Yay! Which makes this problem just that much more easy. So I'm going to raise both sides to the reciprocal, which is 3/1. But 3/1, isn't that just 3? Right? So all I'm really doing is cubing both sides, which is kind of nice. So the 1's divide, the 3's divide, and I'm just left with 2x minus 5 on the left side, no plus or minus, and then I'm left on the right side, 3 cubed. Well, 3 cubed, that's just 27. So now I solve, which is a little bit easier because there's no plus or minus. So 27 plus 5 is 32. 32, I'm going to divide both sides by 2 and get x equals 16, which is my potential answer. Potential because I have to check. So I have 2 times 16 minus 5 raised to the 1/3 is supposedly equal to, that's why we put the question mark there, 3. So that's 32 minus 5 raised to the 1/3. 32 minus 5 is 27. 27 to the 1/3. That's the cube root of 27 raised to the 1 is truly 3. So this answer does work. Again, if it didn't, you just put a little line through it, cross it off, and then that would be no solution if you didn't have any other solutions. Okay, so next we have the quadratic form equations. This is the one where we're going to use U substitution. So the reason we want to use U substitution is because this exponent is double the second exponent. You have 3 terms, it equals 0, and the third term is a constant. So those are all reasons why this looks like a quadratic formula, quadratic equation, but it's not really a quadratic equation. It's of the quadratic form. It's close. So we're going to use our quadratic knowledge to help us solve this. So we are going to let u equal the middle term's variable part. That's the middle term, its variable part. Because the first exponent is double the middle term's exponent, I always get a u squared on the first substitution. Now if there was a coefficient here of something other than 1, you'd need to bring that down with it, but it's just a 1, so it's not that big of a deal. Minus 7 times u plus 12 equals 0. At this point I need to solve. I can factor this pretty easily. Minus 3 minus 4 multiplies to positive 12, it adds to negative 7. I set each of these equal to 0. And I get u is equal to 3 and u is equal to 4. Cool, I solved for u. But no one asked me to solve for u. I'm the one that brought u into the problem. So now I have to take it out. So I'm going to replace u with x to the 1/3. So x to the 1/3 equals 3. And then x to the 1/3 equals 4. Now I'm going to raise both sides to the reciprocal, like I did on the last 2 problems. The reciprocal of 1/3 is just 3, so that's nice. So we have x equals 3 times 3 times 3, which is 27. And then x equals 4 cubed, which is 64. Those are my 2 potential answers. And again, potential because I have to do the annoying check. So when I plug in 27, I'm getting 27 to the 2/3 minus 7 times 27 to the 1/3 plus 12 is supposedly equal to 0. So 27 to the 2/3, that's the cube root of 27 squared, minus 7 times the cube root of 27. So that's the cube root of 27 is 3, and 3 squared is 9, minus 7 times 3 plus 12. So 9 minus 21 is negative 12. And negative 12 plus 12 is 0. It did work. Okay, so 27 works. let's go back and check 64. So 64 to the 2/3 minus 7 times 64 to the 1/3 plus 12 is supposedly equal to 0. So that's the cube root of 64 squared times minus 7 times the cube root of 64. So the cube root of 64, that is 4. Because 4 times 4 is 16 times another 4 is 64. So we have 4 squared minus 7 times 4, which is 28, plus 12. 16 minus 28 is negative 12, and negative 12 plus 12 is 0. So it works. Yay. And that is the last one we're going to have to check on this. So that's awesome. Okay, so the next one, we're doing another u substitution. We let u equal the middle term's variable part, which in this case is x to the negative 1. Notice that the first exponent is double the second exponent, and there's 3 terms that equal 0, and the third term's a constant. So those are all reasons why it's a quadratic form problem. So x to the negative 2 turns into u squared. Minus 5 times x to the negative 1, well, that's just u. Minus 14 equals 0. So that's factorable. So I'm looking for two numbers that multiply to 14 and add to 5, and that's 7 and 2. They have to be one of each sign because the 14 is negative, and they have to add to negative 5, so that's a negative on the 7 and a positive on the 2. I set each of these equal to 0, and I solve u equals 7 and u equals negative 2. Yay! But nobody asked me to solve for u. They asked me to solve for x. So now I have to translate this back into x's. So x to the negative 1 equals 7, and x to the negative 1 equals negative 2. As a reminder, to get rid of the negative 1 exponent, we just raise both sides to the reciprocal, or just negative 1. And what does negative 1 exponent do? Well, the negative times the negative is a positive x on the left. 7 to the negative 1, that's just simply 1 over 7. Notice that the negative in the exponent just moves the base downstairs. It doesn't change its sign. It was positive 7 and it's still positive 7. It's just 1 over positive 7. On the second equation, the negative 1 times negative 1, that's positive 1, so you're just left with x on the left. Negative 2 to the negative 1. This negative in the exponent and the negative on the base do not multiply out to a positive, okay? You can't do that. The negative 1 in the exponent just says 1 over the base. So if the original problem had a negative in it, when you raise it to the negative 1, it just 1 over, and it still has a negative in it. So the two answers are 1/7 and negative 1/2. The negative can go in the top, the bottom, or out in front. It doesn't really matter. Just make sure you only have one negative on the half. And that one does not need checking because there is no fraction in the exponent. All right, for our last problem, it's a higher order problem, which is a factoring problem that's a little bit higher order. This is the first one that has a 3 up in the exponent, which means I'm looking for 3 solutions here, which is why it's higher order. It's not quadratic, it's higher than quadratic. So I'm going to use grouping, which I'm going to group the first two together, the last two together. In the red group, I can factor out an x squared. In the blue group, I can factor out, let's see, 9, positive 9, which gets me 3x minus 5. Notice that the two parentheses are the same. So now I can factor out the entire parentheses, and I'm left in the second parentheses with x squared from the first group plus 9 from the second group equals 0. Set each of these factors equal to 0 and solve. The first one's linear, so that's not too bad. So you get 3x equals 5, divide both sides by 3, and you get x equals 5/3. I don't have to check this one either. Yay. Unfortunately, the second one is quadratic. So if this could factor more, you would, but there is no such thing as sum of squares. So what I'm going to use is square root method. I think that's pretty convenient on this problem. So I move the 9 over. I'm going to square root both sides. The square root of x squared is just x. The square root of negative, that's an I. Square root of 9 is 3, and anytime you take the square root of both sides, you have to take the plus or minus part. Do you remember when I said we were looking for 3 answers? Do I have 3? Yeah, I do. I have 1 and the 5/3, and then 2, the positive 3i and the negative 3i. So the answer here is 5/3 and positive and negative 3i, which is 3 total answers. And that concludes our lesson on the practice exam 4, so I want to wish you the best of luck on your upcoming exam.